Arc welding is an electrical process which unites metallic parts. But it is much more than that. For out of the sputtering sparks have come all manner of wonderful and useful things that have made our lives in this mechanical age so continuously exciting and amazing. Arc welding won recognition as long ago as the First World War. In that grave national emergency, it was arc welding the Army called on to repair its trucks and other vehicles.
How you coming, buddy?
All right. I'll be done in about an hour.
You will? Say, that's great. Believe me, boy, you're fast.
Oh, I know, world beater. It's just it's fast.
Does a neat job, too, doesn't it?
The Navy, too, discovered arc welding and turned to it for reconditioning ships that had been sabotaged by the enemy before we seized them.
Say, that looks as good as new.
That's just what it's going to be when I get through.
Thought at first we'd have to install a new pump.
That would have taken days.
Yeah, well, you've only taken hours.
Mark my word. This is going to be a great thing after the war.
In those days, arc welding was accepted as an excellent repair tool. But in spite of its wide use by the Army and the Navy, for years after the war, industry as a whole was reluctant to change over, hesitating to abandon the old metals such as cast iron and the old methods such as riveting and accept the new process of welding. The experience of this fiery young champion was typical.
Morning, Robert.
Good morning.
Well, what great idea have you on your mind today?
Well, it is a great idea. I'm sure of it. Let's begin with a wheel that we use on one of our machines. It's cast iron. Now, here's another, just about the same size, only this one is arc welded steel. I think we all know that cast iron is brittle. I think we also know that steel is tough. Now let's compare their weight. The cast iron wheel weighs 13 pounds, and the steel wheel only 8 pounds, which means you use just a little more than half as much material with no sacrifice of strength. And remember that today rolled steel costs about half as much as castings. What about the rigidity?
Steel is stiffer than cast iron, Ray, and I can prove it. Out in the shop, I placed a weight on the end of a bar of cast iron and measured the deflection. Then I placed the same weight on the end of a bar of steel. The deflection of the cast iron bar was 2 1/2 times greater than that of the steel, which proves the rigidity of steel when compared with cast iron.
Even now, I can hardly believe it.
Well, I had to make those tests to prove it to myself. But here's something that ought to be completely obvious to everyone. Just think of the operations involved in casting. First, you have to make a detailed pattern drawing. Second, you make the pattern itself. Third, from the pattern, you make the mold. Fourth, you pour metal into the mold to make the casting. Fifth, you have to machine most castings before you use them. It's a long, slow process that involves a needless amount of time and labor. Making an arc welded wheel is a short, quick job. After the rim is cut and rolled to shape, it's placed in the jig along with a hub, which is a piece of tubing. The 2 spokes, which have been shaped by stamping, are placed next. Now the spokes are quickly welded to the hub and to the rim. And there you are. The entire assembly and welding operations take less than 3 minutes.
Hey, that is a short, quick job.
Well, things are moving fast in our business. We all know there are many changes that we would have made if it hadn't been for all those casting operations. With welded steel, it's not only easier to make a part, it's also easier to change it whenever an improvement is suggested.
But we've been using cast iron for years.
Yes, and we got along without the telephone or the electric light for centuries.
All right, Bob. Go ahead.
Well, here's another piece we use, a riveted joint. It consists of the 2 plates to be joined, 2 splice plates above and below, and 8 rivets, a total of 12 pieces. Now here, the same 2 plates are arc welded, and this one will do the same job for us as the riveted piece and do it better. Let's compare them. In the first place, the riveted part is much heavier than the arc welded part. Now think of the material you would save there. To rivet these 2 pieces together, you have to add 2 more pieces and also 8 rivets. That means that you weaken your material by punching 8 holes in it, and then you try to make up for that by plugging those holes with rivets. And think of the time saved. For one welder can do the work of 3 or more riveters in any comparable job. Of course, you can see for yourselves the simplicity of the welded joint, how clean it is when compared with this awkward, bulky, riveted piece.
You say that if you solder 2 pieces together, the joint will be stronger than if they were riveted?
In the first place, they're not soldered. There's no glue holding them together. The 2 pieces are fused into 1 piece, and it's stronger than if they were riveted. I'll ask you to clear your minds of all past experiences with old methods, and to say truthfully, if you had a job to do, how would you do it? With cast iron, with riveted steel, or with arc welded steel? Well, understand, I don't suggest that right now we substitute arc welding for cast iron and riveted steel in every case. But if we do make a start, unless I miss my guess, we'll be using arc welding more and more.
That's all very interesting, Robert. Suppose you let us talk it over.
And so gradually, the skeptics were convinced. And one industry after another adopted the new process. But before we see what arc welding has done and is doing, let's first find out just what it is. The primary purpose of welding is to unite metallic parts. These 2 plates are to be welded together. Because arc welding is an electrical process, we must provide the necessary current. It comes from this welding machine, which delivers the right type and size of electric arc for every job. The electric current flows from the welding machine through a cable to an electrode, which comes in contact with the plates to be welded. The current passes through the plates to the table on which they rest, and through another cable back to the machine, thus forming a circuit. The welder wears an apron, sleeves, and gloves of chrome leather to protect him from the flying sparks and the heat. He must not look at the arc except through the dark lens of the head shield, for otherwise his eyes would be temporarily affected. The electrode is placed in a holder. It is a coated wire that melts as it's fed into the arc and combines with the edges of the plate, which have also been melted by the heat of the arc. Experts use as large electrodes as possible, for speed goes up as the size of the electrode is increased. Without turning on the current, let's see the movement of the electrode in striking an arc. First, contact is established with the plate. The electrode is raised and then lowered to the correct welding position. Now that the welder has adjusted the machine to provide the correct current, he starts it. The electrode in its holder is brought into contact with the plate and an arc is struck. Its temperature is over 4,000 degrees Fahrenheit. Both the tip of the electrode and the plate are instantly melted, and the metals are mixed or fused in a weld that joins the 2 pieces. Now we can see plainly how the metal of the electrode takes the form of tiny droplets. As a matter of fact, they are driven across the arc like bullets with such force that a crater is formed in the molten metal. Notice that as the electrode travels along the joint, the metal is forced to the rear of the pool. As the coating of the electrode is consumed, part of it is changed into gases that serve as a blanket to protect the pool of metal from the air. Unless molten metal is protected, it absorbs oxygen and nitrogen from the atmosphere, which impairs the quality of the steel. But those clouds of gas shield the molten metal from the air and thus prevent the formation of harmful oxides and nitrides. The coating also forms a slag that protects the bead while it is cooling. After removing the slag, this is the bead with its series of uniform ripples built up from the metal of the electrode and the work to be welded. There are three common types of welded joints: the butt weld, the T-weld, and the lap weld. There are also three principal positions in welding. Here, a T-weld is made in the downhand or flat position. Here, in the vertical position. And here, in the overhead position. Learning welding is not too difficult. The fundamentals can easily be mastered in a month or so under the direction of a competent instructor. However, to make perfect welds of all sorts, in all positions and with maximum speed, involves considerable experience. Another important function of arc welding is to build up surfaces that have been damaged or worn away. This welder is adding metal to the worn ends of streetcar tracks. Most of us have noticed that operation, but probably we didn't know much about it, except that it hurt our eyes if we watched. And the man in the street still isn't aware of the prominent part arc welding plays in his life.
In my life? I'd like to know just what arc welding has to do with me.
Well, let's see. Would you say you're an average American?
I suppose so.
Then you own an automobile, and you've had at least one repair job done on it.
At least one, brother.
Maybe you had a bumper knocked off. You certainly didn't buy a new one, but instead you had the bracket arc welded. Arc welding is also widely used for repairs and maintenance by steel mills, mines, and railroads. It offers a quick and economical way to put back into service worn parts, broken castings, forgings, and gears. Machine tools built by arc welding are now replacing older types. Take this gigantic hydraulic press. It's an example of properly designed welded machinery that's lighter, better looking, stronger, and more rigid than if made of cast iron. And it costs less, too. The builders of automobiles were the first mass producers to go all out for arc welding. Steel body stampings and fender subassemblies are welded together. Axle housings, fuel tanks, and bumper assemblies are simple welded fabrications. In fact, riveting and bolting have been almost entirely eliminated. Also arc welded are the frames of road scrapers, steam shovels, and cranes that build and maintain the roads over which our cars and trucks travel. Once a black puffing giant, the railroad locomotive is now streamlined, sleek and shining, and gay with color. In one shop, the cost of fabricating the frame of a locomotive was cut in half by welding. And also there was a 25% saving in weight. The couplers are mostly welded, rolled steel plate for weight reduction and greater reliability. These big diesels are a most economical source of power for hauling both passengers and freight because their weight has been so greatly reduced, in some cases as much as 200,000 pounds. Builders of peacetime commercial airplanes with characteristic foresight were not slow in adopting arc welding, for it meant more dependability and less dead weight, essentials in the manufacture of aircraft. A lighter plane made higher speeds possible, and greater strength increased the safety. On these slender tubes of steel are mounted the powerful engines that drive the plane. You'd hardly believe they could support the heavy power plant, but they do because they're welded. Now let's look at the petroleum industry that provides the fuel and lubricants to keep our cars and trucks, railroads and airplanes moving efficiently up and down and across our country. In 1930, with the introduction of shielded arc welding, the oil men turned to welded construction for refinery pressure vessels, by which in some cases they were able to maintain pressures up to 5,000 pounds per square inch, or more than 150 times the pressure in your automobile tires. Such high pressures combined with high temperatures are not possible with any other method of construction. With towers like this one, the gasoline yield for every barrel of oil was doubled, and at the same time the quality and octane content of the gasoline improved, the cost went down, and motor car performance went up. This improved lower cost fuel made possible our high compression, lightweight engines for new motoring economy and enjoyment. In 1935, 25 million cars were rolling over the roads of the United States. But there wouldn't have been nearly so many if it had not been for low-cost welded automobiles and improved low-cost fuel from welded refineries. And instead of new cars rolling off the assembly lines by hundreds of thousands, production would have been much less, and also the payrolls of such related industries as steel, aluminum, rubber, glass, and upholstery would have been many times smaller.
I'm beginning to think you're right. You know, you might even have me looking for welded things.
Then look up. Nowadays, with new construction methods, buildings can soar up above the streets without the ear-splitting din of the riveter, for most modern buildings have arc-welded frames. Bridges that are flung across rivers and bays are sturdier and stronger and safer because they're arc-welded. Dotted about the country are streamlined water towers, striking in their rounded symmetry, faithfully serving their communities. And they, too, are arc-welded. Among the most majestic achievements of the decade before the war was the construction of such massive dams as this one at Shasta, by which water from streams and rivers was held back, later to transform the wilderness and the solitary desert and make them blossom as the rose. And the pipes that direct the water for irrigation and also for the development of power are arc-welded. The rushing waters are harnessed and their surging drive is converted into electricity in welded turbines. On towers that stride across the countryside, that power flows through wires into your home. There too you will find that arc welding has contributed to our comfort and convenience. It was used in the fabrication of the kitchen furniture. The stove frame is arc welded. And so is the refrigerator. Why, actually, the very food we eat may well have been produced with the aid of arc welding. The sturdy harrow is arc welded to give it greater strength and long life, and so are parts of many other farm implements. There was a day when the farmers of the country, with the help of these modern tools of agriculture, were faithfully going about the essential business of filling America's market basket. In the amazing world of tomorrow, arc welding will be more than a process, more than a tool. It will be a magic wand, and when it strikes, we can envision through the cloud of sparks greater safety and security, more freedom and more happiness, the richer, fuller, and more useful life that so surely will be ours in that brave new world we shall create.